Hello, class. This is the 3.1D lesson, and it is on graphing linear inequalities. Okay, very similar to just graphing uh, lines in general, but obviously there will be a shaded portion because it is uh, an inequality this time. Okay, just like we've been solving equations, you always want the variables all on one side. You always want the constants on the other side. And obviously, we remember the rule of if you ever multiply or divide by a negative, you must switch the inequality sign. Okay? So there are tons of routes that you can go whenever you solve these inequalities, but I'm just going to go with the route that speaks to me immediately. So for number one, do we all notice that there is a fraction coefficient, the negative 1/2? Uh, I am actually going to then take this entire inequality and I'm going to multiply by 2, right? That would actually help me relieve me from this fraction. So I'm going to get 8n minus 18 less than 6 minus n, right? All I did was I multiplied every term by 2. Uh, you then want to kind of push all of the variables to one side. So I'm going to add n to both sides, and I get 9n minus 18 less than 6. Okay, I'm going to leave a little bit of space for my my graphing portion of the inequality, and I'm going to add 18 to both sides. So then I get 9n is less than 18 plus 6 is going to be 24. And then I divide both sides by 9. Okay. Now, also remember that you do have to simplify whenever possible. And in this case, we have a common factor of 3. So I know that I could divide 24 by 3, which is 8, 9 divided by 3, which is 3. Final answer. Okay, really similar to solving an equation, except you just have to follow the rule of if you ever divide or multiply by a negative, you have to switch the inequality sign. Okay, so let's go ahead and graph. We know that 8/3 is 2 and 2/3. So realistically, I just have to do a 0, maybe a 1, maybe a 2, and then a 3. Maybe give me a negative 1, 2. You don't have to provide that much detail, but we know that 8/3 is 2 and 2/3. So this is literally where it is. And we know it's an open circle. It's an open circle because we cannot include 8/3. And we also know that the arrow is pointing to the left. So all you have to do is shade to the left. Right? And then you're done. Okay, let's try a couple more. Let's try number 2. Number 2 looks pretty complicated right now, but the first thing I like to do whenever I see a situation like this is I like to distribute. So I'm going to distribute the 2 to the 4 and the a, and I get 8a plus 2a minus 1/2 a is greater or equal to 3/2 a plus 20. How many times did I just say a? Okay. I just messed up, I noticed, and this happens, it could definitely happen to anyone. 2 times 4 is not 8a, it's just 8. So I messed up on that part. It's just 8. Okay. Always review your work when you do a long step like that. So it's just 8. And then I get, you know what? Let's go ahead and multiply the entire inequality by 2, right? So then I get 16 plus 4a minus a is greater or equal to 3a plus 40. I'm starting to notice something. I don't know if you see what I see, but I'm starting to notice the 4a and the negative a becomes 3a, 16 is obviously still there. 3a plus 16 is greater or equal to 3a plus 40. Now, we talked about this in Module 1. We have the same variables, same amount of variables on both sides. So really, they just cancel out. So you have to ask yourself, class, is this a true statement? Is 16 greater than 40? Right? That doesn't sound true. That doesn't seem true at all. The 3a's cancel, and this is not a true statement. 16 is greater than 40 is false. So whenever it's false, we don't have to shade anything, and we know the answer is no solution. Okay? If it was a true statement, then you would say infinitely many solutions. Right? So this is really, really important. Maybe you want to put a star next to this one because this is a special situation where the actual inequality statement is not true. You can tell, class, that these questions are getting a little bit more complicated. Look at how much work I showed just to do one problem, right? That's kind of expected of you at this point. I do like number 3. I do like number 4. Let's go ahead and just do both, okay? For number 3, you could see that there is an expression as a numerator on the left side and an expression as a numerator on the right side. What I would do, just like you would do with an equation, is you should cross multiply here, right? Essentially, class, we're multiplying by the LCM of 15. And if I multiply by 15 on both sides, you basically just multiply the top by 5 and on the left side and the top by 3 on the right side. That's essentially multiplying by 15, right? Because 15 divided by 3 is 5, and 15 divided by 5 is 3. So now I get this new inequality that looks just like this. Okay, so now I'm going to distribute, and I get 10 minus 5x is less than or equal to 3x minus 6. Okay, seems like there's going to be a potential of a negative variable here, so definitely want to be careful. I like to keep the variable on the left side, but however the variable is negative, that's okay. I don't mind. I'm going to subtract 3x from both sides. And actually, I'm also going to just subtract 10 from both sides, right? We are at the point where we could actually do 2 steps in one. The reason why I subtracted 10 is because I wanted to get rid of this constant and just push it to the other side. I also got rid of the 3x on the right side, which is our goal, right? So I get negative 8x is less than or equal to negative 16. Okay, this is pretty much like Module 1 all over again. Just please be careful here. I now am going to get rid of the coefficient of negative 8, and you can already tell I'm dividing by a negative. So if I divide by a negative, your attention should really be on this inequality, right? The inequality must switch. Okay, final answer is x is greater or equal to 2. That's really not that bad to graph at all. But I think the challenge of this question was to navigate your way to the answer, right? That was the hardest part. And this time it is a closed circle because it's inclusive of 2, and you shade to the right. You always want to keep your variable on the left side so you can follow the arrow, right? I purposely chose to subtract 3x to the left side because I wanted to keep the variable on the left side so I can then follow the arrow when I'm graphing. Okay. Last question on this page, on this section, number 4. I love this question because I've been stressing this since day 1. 7 minus 2 is a trap, right? We do not do 7 minus 2 ever because we know that multiplication goes before subtraction. So make sure you understand to distribute the negative 2 to both terms, distribute the 5 to both terms, and then the 7 gets to join the party afterwards. Okay, so negative 2m plus 8, right? That negative 2 times negative 4 is negative 8. This is 5 minus 10m. And then the 7 is like, hey, everyone, welcome back. Okay, I'm going to go ahead and add 7 and 8, get 15. So negative 2m plus 15 is greater or equal to, I'm going to rewrite this just because I want to show the class that we can, negative 10m plus 5. You could always rewrite that using the commutative property, right? Okay, so now our fortune tells us that I could add 10m to both sides, and that gives me, not only does that give me a positive variable, it also pushes the variable to the left side. I'm also going to do negative 15 on both sides. I'm going to subtract 15 because I want to cancel the constant. Okay, I'm doing 2 steps in one just because I feel like we're capable of doing that now, right? Moving all the variables to one side and moving all the constants to the other side. I then end up getting negative 2m plus 10m is 8m. And then 5 with negative 15 is negative 10. Just divide both sides by 8. Obviously, you want to simplify. Negative 5/4 is the final answer. Okay, so let's go ahead and label a little bit. Negative 5/4 is negative 1.25. So we know that if it's somewhere, it's between negative 1 and negative 2, and it's pretty much the first line out of the 4. We know it's an open circle, and we shade to the right. Okay, so that was really, really good practice on solving and graphing linear inequalities. You definitely want to be proficient at this. You want to make sure, look at how much work I've shown, and you want to be very, very comfortable with just, the bread and butter of solving a linear inequality. Okay, let's shift gears a little bit, and now let's talk about how to graph a linear inequality. Okay, now the good news is it's actually very, very similar to graphing just a regular equation, right? So number 5 says graph the line y equals 2x plus 1 on the coordinate plane. State the slope and the y-intercept. Okay, so we know that the slope here is 2. We know the y-intercept is 1. And that's going to be the same for an equation or an inequality, right? This doesn't change. Start at 1 and go up 2 over 1, up 2 over 1, up 2 over 1. Okay, down 2 and left 1. You also always want to give some points that are below. Okay, so since this is an equation, we connect the dots and we just kind of bold the line, right? Well, in an inequality, what would it look like if it was less than this entire line? What does less than mean? Well, we kind of, practice that less than means shade to the left and greater than means shade to the right. In this case, because we're dealing with the y-axis, less than really just means shade below, and greater than or equal to means shade above, right? Instead of going left and right this time, we are now going to shade above or below. So if we were to graph y less than or equal to 2x plus 1, this is the graph. This is the same line, so we still have to plot it like this. But now we ask ourselves, which way is that arrow pointing? Right? Because the arrow is pointing left, that's basically saying to shade below. And everything below the line is going to be shaded. Okay. That's how you shade a linear inequality on a graph. Okay. Now there's one other thing I want to talk about, and it's the fact that this was a less than or equal to sign. Less than or equal to sign and a greater than or equal to sign means it's a solid line. And then the less than or greater than sign is a dotted line. I could talk about that more in detail, but just remember that just like an open circle and a closed circle, a solid line means it's closed, and then a dotted line means it's open, kind of like an open circle. Okay. Predict what the graph of y greater than or negative 1/3 x minus 2 might look like. How will it differ from the graph of y is less than or equal to 2x plus 1? So there's many things you can say about this, right? First thing is one's a dotted line and one's a solid line. One is dotted and one is solid. Secondly, one is shaded below and one is shaded above. They're shaded in different directions. Okay. So go ahead and graph y is greater than negative 1/3 x minus 2. So always start at the y-intercept, 0, negative 2. Then your slope is negative 1/3. So that means you go down 1 and 3 to the right. Down 1, 3 to the right. You can also go up 1 and 3 to the left. Up 1 and 3 to the left. Okay, now because this is not a solid line, this is just a greater than sign, you cannot technically connect the dots. You can just create a perforated kind of like dotted line situation. And it's telling you to shade above, right? Shade above. That's the greater than sign. So shade above means you shade everything here. You have to shade whenever you're graphing an inequality, right? Just like what we did in the first half of this page, you always have to shade whenever you're graphing a linear inequality. All right. Let's take a break right now, and I look forward to creating part 2 of this lesson.